Welcome to the project demonstration of IoT ECG monitoring with disease detection using machine learning with the help of Raspberry Pi 3 B+. So here we are going to take the ECG readings from this ECG electrodes, and that was given as input to the AD8232 ECG module, so which will convert the ECG signal to analog voltage along with the digital input. So the digital input pins are the identification for the ECG electrodes mounted properly or not, and analog input is the exactly ECG values. So that was connected to the Arduino Uno. Why? Because Raspberry Pi can't read the analog values as it doesn't have the analog to digital converter. We are using Arduino Uno to convert that particular analog values which is coming from the ADE8232 ECG module to serial. So for example, if we are getting the analog value of around 600, right, so the analog data will be converted to the serial data. So as we discussed, if we are getting the 600 value from this AD8232 ECG module, and that value will be converted into the serial 600, and that was a serial input to our Raspberry Pi 3 B+ at receiving pin, and from there a Raspberry Pi 3 will store the data around, it will take 50 samples, then after it will compare with the trained data set already. So means we already trained the data set which is to use to detect the diseases with the help of this ECG data. So and the predicted ECG values and the disease values will be displayed on this LCD screen. At the same time, we are going to send that to the Blink application to monitor the same values on this Blink app LCD display. So here we are using the switch to select this auto mode and manual mode. In auto mode, it will check the readings from the ECG module, and it will compare that stored ECG values with the trained data set, and it will detect the disease by prediction algorithm, and that will be predicted and displayed on the LCD screen as well as into the Blink application. And when we place in the manual mode, we need to provide the data set as an input. So we have already loaded the 4 data sets. So set 1, set 2, and set 3 and set 4. So now instead of getting the data set from the ECG module, it will check with the predefinedly stored data set, and then it will analyze that, and then it will predict the disease, whether it is a normal or abnormal. So that will be displayed on the LCD screen directly. So we have interfaced this AD8232 module at 1110 as a digital input to check the module electrodes connected properly or not. A0 for the analog reading purpose, and transmitter pin of Uno board is connected to the receiving pin of our Pi 3 B+ module, and LCD is connected at pin number 17, 27, 22, 9, 10, 11. And these 4 control buttons are connected at 5, 16, 19, 13, 21 and 26 are connected to this switch and the LED normal indication purpose. So this is the breadboard to distribute the 5 volts power supply for the input and output modules. So here, before on the kit, the very first step is we need to install the Blink application. So the Blink IoT, which is available in the Play Store. And the next step is go to hotspot. As by using that hotspot only, our Raspberry Pi will upload the data to the ThinkSpeak. So change the hotspot name to, if you are using the iPhone, change your iPhone name to Project 5922. If you are using Android phone, just follow these steps. So PROJECT 5922 without any space, without any capital letter, and password should be 123456789, and AP band should be 2.4 gigahertz. After these settings on the hotspots, on the data, and now this is the ECG gel, just for under, don't like place any copper or steel objects in your hand. So left side, right, 1 electrode, and right hand 2 electrodes. One is at wrist end and another is the elbow section. So we will provide this gel also, and then on the power supply, so it will take around of 30 to 40 seconds for the booting purpose. let now on this power supply to that. Okay, so let us place this in manual mode. So because I didn't mount these electrodes now you can see one device will be connected after successfully booting, and also it will display the welcome message on the LCD screen, and this particular LED will getting on and off 2 times. So as we discussed previously, we can see the offline string on the blink application as the device was not connected to the internet. Yeah, right, you can see one device was connected. So this is must, we should check. If it is not connected, there is indication of something right. So as you can see the welcome message, and now it's in data set mode and it is online now. So let us check. So just I'm loading the data set 1. So meanwhile I'll mount this. So you can see the data set 1 loading and analyzing. Normal. So data set 3. This is prediction and analyzing, and then after the particular disease was displayed after prediction died. Okay, and here we can see the R. So there you can see R, nothing but right side, right hand, and L for left, and R. So just mount it. Right, and now place it in auto mode. Right, so if it is asked you to insert properly, then insert that as is shown here. So the black color, yellow color at the left hand side, right, and the red side at the wrist end, and this green color at the elbow section. So wait for some time to be stabilized one. Right, you can see that it is coming normal now. Right, heart rate also will be displayed. So only the thing is, while we demonstration, we are not supposed to mount any copper or any other gold items on your hand near these electrodes. It will provide us the abnormal details. So we set the disease detection algorithm for lower sensitivity, as a normal person won't get the diseases. That's why we are placing that to get the diseases for demonstration purpose only. So we are getting that. Okay, so in this manner, manually in auto mode, we are going to get the ECG values with decision prediction algorithm to identify the diseases. Right.